In this lecture, let us learn about modes of oscillations. Let us see how the bunching of electrons creates a sustainable microwave signal. In the previous slides, we saw one cycle of sine wave creating the bunching effect. In reality, the cavity resonator is creating continuously such sine waves. Let us consider multiple cycles of sine waves as shown here. In practical klystrons, it takes more than one cycle to create a bunching effect. Consider the same example of three electrons. While electrons A and C experience accelerating and retarding voltages respectively, electron B did not encounter any extra voltage from the cavity. So this electron is considered as our reference electron. Before going into further explanation, let us recall that the positive peaks of the sine wave push the electrons faster towards the reflecting electrode, while the returning electrons, these peaks, slow down. Because the positive peaks have pushing effect. Thus the electron speed has opposite effect for the positive peak and for the negative peak. To create bunching, or to capture energy from these electrons, we want the speed to be lowered. Else the returning electrons will gain speed and move towards the acceleration grid. Let us put together the varying field created by the cavity, which we call as the sine wave and the bunching effect. Look at this image. Consider the three red dots. These represent time instances of three electrons A, B, and C. Due to accelerating voltage and cavity resonator field, the electrons are moving towards the reflecting electrode. We know that these electrons, which are at different time instances, are subject to accelerating voltage, reflecting voltage, and the cavity field. These things cause bunching. Bunching happens when the field is maximum or when the returning electrons are slowed down. From the image, consider electron B, which is at the center, and our reference electron. This electron did not undergo any acceleration or retardation while moving forward, but on the return path it gets pulled when the field is maximum. Field is maximum here. This electron has zero effect from the field, and we see that such zero field points occur at multiple times. These are zero field points. In this example, we have considered a case where there are two cycles of the field from the reference electron point. This is one cycle. This is the second cycle. Two cycles. We know that for the bunching to happen, the field has to be maximum. This point is also shown in the image. Now if you calculate this point, it is 1/4 cycle less than 2 cycles. So we can say that bunching happens at 1/3/4 of a cycle. Now this can be generalized to say that bunching happens at every n is equal to n plus 3/4 cycles, where n is equal to 0, 1, 2, 3 and so on. This example is where n is equal to 1. Based on these three major parameters, which is mechanical design of the cavity, reflector voltage, acceleration voltage, bunching happens. So let me repeat. Based on the three major parameters, which is mechanical design of the cavity, reflector voltage and the acceleration voltage, bunching happens. So if we consider mode 1, then it means that for every 3/4 of a cycle there is bunching of electrons and oscillations continue, which are taken out through a coaxial cable as microwave signal. When mode is 2, microwave signal is generated every 1/3/4 of a cycle, and this process continues.